Okay, so in this one, we are transitioning from expressions that we've been working on to equations. The main word that you are going to notice that is different right now is the fact that in expressions, the directions asked you to simplify. There was no final solution, therefore there were no equal symbols. Now that we are transitioning into equations, you're going to see the term solving or solve, okay, or solution. That means that you can come up with one answer. The nice thing is that if you solve a one-step equation, you can then take your solution or the answer, plug it back in, and check to make sure that you are correct. Whereas with expressions, there really was no way to check and make sure that you had done the work right. Okay, so the good news is I should never have to correct and tell you you're wrong because you should be able to do that yourself. Okay, so when we are filling in these blanks on the assignment, right here, in order to solve an equation, we must isolate the variable and keep each side of the equation balanced. Okay, so basically, if we are isolating the variable, that is the letter, okay, we are keeping it on one side of the equal symbol and having all of the other information on the other side. Once we simplify it down, work our way through it, we will end up with a variable on one side and a constant on the other, which will demonstrate what it equals. Okay. The sentence right here, we can use inverse operations to move terms from one side of the equation to the other. Inverse operations can be thought of as the opposite or undoing the operations. Those are the two blank lines there. I'm actually going to not fill those out. And if you are listening, you should be able to do that yourself. Okay. So the inverse operations, if I asked you to add, then the inverse operation would be to subtract. Okay. If I asked you to subtract, the inverse would then be to multiply, to add. If I asked you to multiply, the inverse would be to divide. And if I asked you to divide, yep, we would want you to multiply. It's like if I asked you to tie your shoes, eventually the inverse would be that you untie your shoes. Okay, so with that information, we are going to do inverse operations to work our way through these one-step equations. They're one-step equations because you literally will only see one operation in each one. Okay, we talked before about when we have a coefficient next to that variable, that means to multiply. So really what this is saying is 4x or 4 times x equals 16. Okay, so if I want to undo this operation, I am going to have to divide, like we discussed before. The multiplication problem gets undone by dividing. Okay, I need to divide by the number that is next to the variable so that I isolate x all by itself. Okay, so 4 divided by 4 cancels it out and just leaves x. But whatever I do on the left side of the equation needs to also be done on the right side of the equation so that I can balance it. I can't change one side without it affecting the other. It's similar to you riding on a teeter-totter with somebody, right? If you both have the same amount of weight, okay, you're going to be balanced. But if a heavier person jumped on one side and now you have two people on one side, the person with only one person gets raised up into the air because they weigh less, okay? So if I were to rewrite this right now, I would have x is equal to 16 divided by 4. 16 divided by 4, whether you use a calculator or know your basic facts, equals 4. Okay, so x equals 4 is the answer. Now, how do I check this? Okay, well, the easiest way to check this would be to plug in what I believe is the solution, okay, into the original equation. Okay, so if I have 4x equals 16, I'm going to take out the x because I said it equaled 4. And I'm going to go 4 times 4 equals 16. Okay, and I would definitely use a calculator on this one. I know in these simple problems, you should already know the answer, which the beauty of using a calculator is you should agree with whatever comes out if you know what the answer should be. Okay, I'm strongly going to encourage that you show work and follow the process that I'm teaching you, because while all of these are simple enough that you can come up with a solution, okay, I'm training you to learn the process so that I can give you more complicated problems. If you ignore the steps now, you're going to be the people who can't do the two-step equations because you didn't learn the process in the first place. Okay, so there's my little reminder. Okay, in number 2, this is an addition problem, so the inverse of it would then be to subtract. I'm just going to point out that you're always going to start by getting rid of the addition or subtraction portion of the problem. Okay, remembering, okay, to get rid of this. How do you get a 0 pairing? Going back to the last unit. Well, if I have a positive 9, the way to turn that into nothing is by giving a negative 9. Okay, so now that is gone from this side, and all I'm left with is x. I still have to do the same thing on the other side. So what I'm saying is 13 minus 9. And oh my goodness, I'm getting 4 again. Okay, so now I'm just going to show you a simple way if you don't use all the space in the box. You could take the original problem, x plus 9, okay, equals 13. And then I would take the x out and actually substitute it for what I said it's equal to. So 4 plus 9 equals 13. That's a true statement. Therefore, I have solved this problem correctly. Okay. 2 more to go just so that you get an idea. So again, we have a negative 8 or a subtracting. Therefore, I'm going to do the inverse and make it a positive. Okay. That cancels that out. And this side is just left with an x. On the other side, okay, 14 plus 8. Okay. And if you grabbed your calculator to confirm you don't make silly mistakes, you would end up with 22. Okay. And again, checking my work, I would take that x minus 8. I would replace the x with the 22. 22 minus 8 equals, actually use calculator to make sure that you don't make silly mistakes, 14. 100% correct. Nice job. For the division portion of it, the inverse of division is multiplication. Okay, so I am going to multiply, and the goal is to isolate the variable. So I actually want to multiply by the 5. Okay, 5x, right? Well, I'm going to get rid of that because I'm actually going to divide 5 by 5, so all I'm left with is the x. I have to do the same thing over here, so I would divide 13 by 5, or sorry, not divide, multiply. I'm actually just going to leave that mistake verbally in there, okay? Multiply by 5, okay? Because I multiplied on the left, I got to multiply on the right, okay? And 13 times 5 is 65. Easy way to check. If I take the x out and I replace it with the 65 and divide it by 5, I get 13, which is what the original equation looks like with the variable taken out. Okay, so now we've done one of each of those. I would highly recommend you continue to practice. As you look down a little bit lower, you are going to notice that they don't all have integers, okay, or they're not all whole numbers. You can also do the same thing with rational numbers, which is actually what goes right there, the word rational. Okay, same exact concept, nothing tricky, right? So for example, in number 8, it's x plus 2.5 or 2.5 is equal to 7.5. Well, if I do the inverse and I subtract 2.5 from both sides, then x will equal whatever 7 minus 2.5 is, which would be 5. Okay, so same concept. I would highly recommend doing a little bit of practice on that so that you can be successful with whole numbers, integers, and rationals. Okay, good luck to you.